In this video, I want to talk about matrices. In particular, I want to talk about how to use matrices and our graphing calculators to solve systems of linear equations. So, a matrix is just a rectangular array of numbers, and we use brackets to denote that this is a matrix. So here I simply have a matrix that has 2 rows and 2 columns. We call that a 2 by 2 matrix with entries 2, 1, minus 1, 3. Here I have a 3 by 4 matrix, and when I talk about a matrix, I always say rows by columns. So this is a 3 by 4 because it has 3 rows and 4 columns. Here is a 2 by 1 matrix and a 3 by 3 matrix. These ones are particularly nice. They're called square matrices because they have the same number of rows and the same number of columns. And you can just think about a matrix as a way to store information. For us, we're interested in what's known as an augmented matrix, where I use a matrix to summarize a system of equations. So here I have a system of linear equations in 3 variables. So I have 3 equations in 3 variables, and I've written it down in this nice way, where I have x's, y's, z's written down in that order in all 3 equations are equal to something. And that's how I need to write down every single system of equations I ever meet to write down an augmented matrix. Even if it only had 2 equations and 2 variables, you could imagine erasing this and getting rid of the z, it would be x, y, and still equals something. My augmented matrix is what I get when I write down just the coefficients off the variables. So I have 1, 4, minus 1 is equal to 20. And so I draw a line here, and this is why we call it an augmented matrix. The line tells my reader that these are the coefficients of the variables, and this last column is for what the equation was equal to. I have 3, 2, 1 is equal to 8, and 2 minus 3, 2 is equal to minus 16. This is called an augmented matrix. And it's very important that I have x's, y's, z's so that I have a column for the coefficients of x, a column for the coefficients of y, a column for the coefficients of z, and finally a separate column for what these equations were all equal to. And so if I think about it, this is a 3 by 4 matrix. And it's a 3 by 4 matrix because I have a row for each equation. And I have 4 columns because I had 1, 2, 3 variables and then an extra column for what they were all equal to. So it's a number of equations by the number of variables plus 1. Plus 1's for the things they were all equal to. And again, my hope is to use a matrix to solve this system. But what I want to do right now is just solve this system so we can come back to this and understand what our calculators are doing a little bit better. So, that's that same system of equations, and we're just asked to solve it. The first thing I notice is that if I add these 2 equations, the z's will cancel. So let's see, that's going to be a 4x plus 6y. The z's cancel is equal to 28. Now what I want to do is imagine multiplying this by 2 so that I can add it to the 3rd equation. So I'm going to multiply everything here by positive 2, and that would give me 2x plus 8y minus 2z is equal to 40. And nicely, I've written these right next to each other, so I'm just going to go on and add them together. So I get 4x plus 5y. The z's canceled by design is equal to 24. All right, I see 4x in both equations, so let's multiply both sides of this one by minus 1 and add those equations. 6y minus 5y, that will just give me y equals 4. So I know what y is. Well, if I look at this equation here, 4x plus 5y is equal to 24. That means 4x plus 5 times 4, because y is equal to 4, is 20. Taking 20 away from both sides, I get 4x is equal to 4. So x is equal to 1. I know x and y, let's use this top equation to find z. 1 plus 4 times 4 is 16 minus z is equal to 20. So I have 17 minus z is equal to 20. Let's take 17 away from both sides. I have minus z is equal to 3, so z is equal to minus 3. So I've solved this system of linear equations. The solution is 1, 4, minus 3. X is 1, y is 4, z is equal to minus 3. So that's a system of equations, but so's my solution if I really think about it. It's a very boring system where x is equal to 1, y is equal to 4, and z is equal to minus 3. So I could write an augmented matrix for that. I would have 1, no y's, no z's is equal to 1. So that literally means x is equal to 1. 0, 1y, 0 z's is equal to 4, so y is equal to 4. And z is equal to minus 3, 0, 0, 1, minus 3. The whole idea behind these augmented matrices is that if I can turn this matrix into that matrix, then I'll be done. I'll have solved my system because I'll be able to tell you what x is equal, what y is equal, and what z is equal to. So there are algebraic methods by which to turn this augmented matrix into this one using what are called row operations. And those row operations are simply a way of revisiting how we multiplied and added equations to each other until we get to here. But the really nice thing for us is that our graphing calculators are actually programmed to do this for us. So that's what I want to talk about next. These instructions are listed on our Moodle page. But our first job is to enter in the augmented matrix to our graphing calculators. So let's do that. So I've written my augmented matrix down. And the first thing I do on my graphing calculator is I hit second, and then this button with the x to the minus first, because the word matrix is written right above it in the yellow color saying, hey, hit second, and then matrix to get into the matrix editor. And we're going to go over to edit because we need to type in this augmented matrix. I'm going to press enter. And here I have to type in the number of rows I need and the number of columns I have. So this is a 3 by 4, so that was already set up. And now I'm going to type these numbers in. And every time I type a number in, I press enter to go to the next one. So I press 1 and then enter. 4, enter. Minus 1, enter. 20, enter. And I've entered in the top row. I'm going to keep doing that. But I'm going to stop saying enter every time because that's annoying. So now I've entered in my system, but I'm going to double check that I've really done it right. And so what I'm going to do is I'm going to read down the columns. 1, 3, 2, 1, 3, 2. 4, 2, minus 3, 4, 2, minus 3. Minus 1, 1, 2, minus 1, 1, 2. And then the final column, 28, minus 16, 28, minus 16. So we've entered in our matrix. This is a step we don't have to do on the calculators very often. We have to hit second and then mode because that's how we quit and get out of that menu. So go ahead and hit second and quit. And now we're going to hit second matrix again. And this time we're going to go to the math menu by hitting the arrow key. Hit the down arrow button until you see RREF. That stands for row reduced echelon form. Row-reduced echelon form is simply a matrix in the format of that one we really want that will tell us our answers, where we see ones down what I'll call the main diagonals, 0 everywhere else, and we'll have constants over here that are our answer, where x equals something, y equals something, and z equals something. All right, so we hit second matrix, we went over to math, we scrolled down to RREF, and we're going to press enter. And now we need to tell the calculator what matrix we were using. So I hit second matrix again, and this time under this first column where it says names, I'm going to choose matrix A because that's where I typed this matrix in. You don't actually have to close this parenthesis, but I feel better doing it, and I'm going to press enter. And there is our reduced row echelon form matrix, 1, 4, minus 3. And that is exactly what we got before. X is 1, Y is 4, and Z is minus 3. So here's my augmented matrix. Here's my row-reduced echelon form matrix, which lets me conclude that X is equal to 1, Y is equal to 4, Z is equal to minus 3, 1, 4, minus 3. The process by which you would do this by hand is called Gauss-Jordan elimination. And it's a super cool thing, but we're going to continue to use our graphing calculators to help us out. When you are using your graphing calculator to do a problem, always write down the augmented matrix that you typed in, the row-reduced echelon form that you got out of the calculator, and then the ordered triple that is the solution in the format X, Y, Z.